What's up guys, Rex here with Micro.AI again, and in this video we're going to be explaining some of the different parameters that you can find in a Micro.AI Launchpad profile. Now we've showed you in some previous videos how to create a profile for security, how to actually launch the package on your devices, but there are some things within creating a profile for your device that maybe aren't as intuitive for some people, or maybe aren't as intuitive mainly because of the name or what they do. Really, when it comes to artificial intelligence and machine learning, there is a lot of linear algebra and math behind it, and we don't want to sit here and give you guys a whole lecture on math, just because it might take too long and we don't want you to fall asleep. So what we're going to do is we're going to explain how the health group parameters, specifically in this video, how the health group parameters affect different things that happen with the health score. So in the previous videos, you've seen the health score. It's a graph that goes up and down based on anomalies that happen, abnormal behavior that the AI detects and predicts and alerts you to. So that's what we're going to go through today. So here I am in my Launchpad account. So I'm on the main page. If you go to your profile page, that's going to bring up all the profiles. I already have it pulled up here. But if you go to profiles and you click on a profile, it should bring up this page here. And we go to the second tab in our profile, and then we go to health groups. So we're just explaining these parameters today. So the health group, these are the parameters that specifically affect the health score, which is the most important piece of data in our Launchpad dashboard, because it's showing the anomalies, and the graph will dip based on anomalies that happen. So let's go ahead and explain these first two parameters. So we have hysteresis and hysteresis 2. Now these help icons here show that these control the speed at which health score increases, but what does that mean? So if you have a device trained, or we have our artificial intelligence trained on this device and it's running directly on the edge device, when an anomaly happens, so let's say you have a robotic arm, it should be doing its cycle in one speed, and for a couple of seconds it speeds up by a little bit. That's going to be out of range behavior. It's going to be abnormal behavior, and your health score, which would be close to 100 or at 100, is going to dip. There's going to be a dip in the health score, but if that change in speed only happens once, the health score is actually going to creep back up to 100. And what that means is that it's going to drop and tell you that an anomaly happened at this time, and then if no more anomalies happen after that one, it's going to slowly start creeping back up. So the hysteresis, these two here, control how fast it goes back up to 100. And anything that's over 1 means that it's going to increase slower than it decreases. And that's typically what we want. We want it to dip and kind of stay around that dip for a little bit so we have time to react to it and see the alert. If it just went bam, bam like that, really fast, like a heart rate monitor or something like that, it wouldn't really give us a good insight as we're using this agent to monitor our device. So we have the default value set at 20 for both. If you decrease them, it's going to dip and increase a little bit faster. If you increase it all the way to 100, it's going to dip and then very, 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 very slowly increase. So that's what these two parameters control. And there's math behind the hysteresis that our AI feeds in, linear algebra and stuff, but we're not going to dive into that at all. This next parameter, which is called aging, this controls the rate of change in the health score. And what that means is, let's say your device, when you train it, all of a sudden it's staying close to 100, but the graph is kind of going up and down just a little bit. Maybe it'll go from 100 to 95 back to 100. So no real big anomaly is happening. That's just what the AI is detecting. The higher you increase the aging, there's going to be less rate of change. So the health score isn't going to change as much. And this is for the like if you have a network channel or network channels, if it goes very, very slightly out of the bounds, the aging, the higher it is, the less change you're going to get for that slightly out of bound detection. So you have your bounds here, and then the actual value, kind of goes slightly out of it. The higher you increase aging, the less the health score will change based on those minor out of bound ranges. And that might be useful for someone who has a more robust piece of equipment. My dad was a diesel mechanic growing up, and we had tractors that would last for years, even if the timing went out just by a little bit, something like that. So if you have a piece of sensitive equipment, though, you can decrease the aging so that the AI is more sensitive to those slight changes. The next parameter here is called memory. And this controls how much previous data is remembered and taken into the calculation of the health score. So remember, there is a lot of math behind the health score, and so memory is also a big part of that. So the higher the memory, the more data is considered, and that may affect how the health score drops. So if we had a big drop, so like let's say we've been at 100 for the whole entire day, for the whole entire shift of the device, all of a sudden we get an anomaly. It's going to drop, but the memory is going to remember that anomaly. So if we get a similar anomaly, like let's say it dropped from 100% to 70% health score, but then we get a similar anomaly, it will drop, but may not drop as much. It may drop down to 65 because it's a similar anomaly. It's not something that's different because it's considering what has happened in the past. And that might be useful for some people, that might not be useful for others, and that's why we let you tune those parameters. So you can make it remember less stuff. So the lower the memory is, the less it's going to remember. So if you get an anomaly that drops down to 70, and you get another anomaly, it may drop it down to 30. So you'll get two big drops, but they could be similar anomalies that happened, or similar out of bound cases. Next parameter here is noise. Now this is the expected false positive rate. And so what that means is when we base a lot of our findings off a confusion matrix where we have true positive, false positives, true negatives, false negatives. And so a true positive means something went out of bounds, and we got an alert from the AI engine, we got an anomalous behavior, and we actually did get an anomaly. And so the higher the noise is, the less sensitive the AI engine is going to be. So you expect that there may be some things that are considered normal that the AI may detect as a positive alert. So it's something that happened that caused an alert or caused an anomaly detection. And so if you know that, you can increase the noise. To give you an example, with the robotic arm, let's say you have a sound sensor on the DC motor, but at the same time you have forklift drivers in the factory that create a lot of noise as well, and they may trigger that sound sensor. So you want to make the sound sensor channel that's being calculated in the health score. You may want to make the noise level higher. Now, noise isn't actual noise that you hear in your ears, it's data noise, but that's just the example I'm going with. This next parameter here is intensity. Now this is a pretty important one. So remember, we had aging, which changed the rate of change. So it decreases the rate of change the higher it goes for slightly out of bound channels. With intensity, if you have channels that go way out of bounds, the higher the intensity goes, the more impact those way out of bound channels are going to have on the health score. So with aging, we had their bounds, and if it slightly goes out of bounds, the higher the aging is, the less the health score changes. But if it goes way out of bounds, the higher the intensity is, the more dramatic the drop is going to be in the health score. And with intensity, we say intensity should not be higher than the number of channels we have. And that's, again, going back into the math behind the health score. So if you have 10 channels, but you want those out of bounds channels to be really, really heavily weighted, you would make the intensity 10, the exact number of channels that you have. But that's going to make, so if one of those channels goes way out of bounds, the health score is going to drop dramatically because that's the highest intensity that it can be. If you don't want that to happen, make the intensity less. Next parameter here, this is days to next maintenance. this is a more scaled version of the health score that we use. So it's the nominal maintenance interval, and then so days to maintenance is a scaled version of health score to the normal maintenance interval, and then subtract out the amount of time that has passed since maintenance has occurred. So if you have a normal maintenance cycle on a device, let's say you check it every 50 days, this is what you would put that number into days next maintenance. We have it set at 40 days, but you can set it to whatever you want. We recommend setting it to your normal maintenance cycle. And then health score will use that to calculate, so if anomalies are occurring in a device and your normal days to next maintenance is 40, but the AI engine's detecting a lot of anomalies and stuff like that, it's going to give you a predicted days to next maintenance. So it's going to predict that, hey, maybe you should check it in 20 days instead of 40 because we've had this many alerts going on. And so that's what health score uses with days to next maintenance. Under this advanced, you will only get the advanced parameters using AtomML Plus and security. With AtomML, you will not get these parameters. So RL, this is what we call remaining life. So this is the remaining number of days of operation that are expected for your device. So if you have a very sensitive device that only has a 2-year life cycle and you've already gone through 1 year, that means you have 365 days left. So you would put that in here that, oh, we expect this device to last us 1 more year. You'd put that in days. The K value underneath it, this is the noise value for the remaining life algorithm because we take in the remaining life days and the noise is the same thing as the noise above. It's the expected false positive rate, but for remaining life. This last parameter over here for PDM, we have 3 algorithms for predictive maintenance. I'm not going to explain 2 and 3, I'll just explain 1. The PDM1 is the default algorithm that we use, and it's used for 99% of our use cases. It basically gives the days to next maintenance and the health score a linear relationship. So for 99% of our use cases, we're going to be using predictive maintenance algorithm 1. We have 2 and 3, and that will probably be a later video explaining the other 2 algorithms. So for 99% of the use cases, you're just going to keep it on 1. You're not going to change this. Okay, but that is the parameters for health group in a nutshell. Hopefully this cleared some things up for you guys, and when you go into your Launchpad account and make a new profile and you are very familiar with your device, now you'll be able to tune it more to what your device's behavior is. And again, you can always retrain the model, you can always retrain the AI and change these parameters over and over again. It just makes a new configuration file that you have to download. So you can change it as many times as you want. But that's it, guys, and if you guys have any inquiries, feel free to reach out to Micro.AI and we'd be happy to get back to you.